In this video, we will look at Instagram's software stack and system design from a top-level view in order to have a general understanding and perspective of how to design the Collabshare platform. So let's get started. Hello everyone, I'm Ramin. Welcome to the Collabshare channel, where we work deliberately to make a beautiful present at our futures. In this session, I will talk about Instagram technology history or Instagram architecture or software stack history, and we will use the same architecture as the initial software stack for our own social network platform. At the end of the session, I will review the materials and I will talk about the topic for the next session. And so let's get started. The initial software stack of Instagram was composed of the following elements: Django plus Apache ModeWSGI. They have used Django for application logic development, and as you know, Django is the Python framework for developing web applications. Also, they used Postgres as the main data server. They used Postgres for storing various data, and in order to decrease the load of their main database, which is based on Postgres, they used Redis and Memcached to store most recently accessed data in a key value pair method. And also, in order to queuing tasks for sharing photos and other use cases, they used German as a task queue mechanism. And also they used Nginx as a load balancer. But after a year or so, they decided to change their software stack in order to improve the quality of their server, and because as you know, their users started to grow in a huge amount, and so they decided to improve the performance of their server. So they decided to change some of the elements in their software stack, and currently their software stack is composed of Django plus ModeWSGI, which is their application logic development. They added Cassandra alongside Postgres to store data. They still use Redis and Memcached, but they decided to switch from German to RabbitMQ and Celery for queuing tasks and other possible use cases. And also they decided to use HA proxy instead of Nginx, because HA proxy has the capability to detect dead nodes. But as you know, these are just general info on how they built up their software stack. Of course, nowadays their software stack is more complicated than this, but you know, simple is the best. We must start with the simplest possible solution that has scalability feature. And by examining their approach, we just want to know how to start and where we are going. Here we want to examine the software stack of the Instagram as a successful social network platform. In order to have a big picture of where we are going, it is a good example of a company that we can see its growth over time. It will give us vision of our Collabshare platform so that we can decide what to do to start and what actions to take in order to grow. This is just like learning from the experiences of other people. We want to utilize their expertise and find our first actions to take. I believe that it can help us to start the journey. Now let's talk about how Instagram's engineers are scaling it on a daily basis. First, let's see what scaling means from their perspective. We can think of scaling as a three-dimensional quantity. The first dimension is scaling out. How we should scale out our platform. The second dimension is scaling up. And finally, how we should scale our dev team. The purpose of this study, this research, is to understand the big picture of where we are going. So studying the scalability history of Instagram will make us to achieve that goal, will make us to create our vision of where we are going. So let's see how these three dimensions mean, and in next slides we will talk more about them. Scaling out means that we need to add more hardware as it is required. So this is the first dimension of scaling a platform. The second dimension is to scale up. In other words, how we can use each server efficiently and with its maximum capacity. So we have multiple servers and we must utilize them with their maximum capacity, and also it must be efficient. And finally, we must also grow our team, because without a growing team we cannot deliver new updates, and we cannot develop our platform in a timely manner. So we need to grow our team to develop platform continuously, and at the same time we must take into account that continuous development without making any trouble is what we are seeking. So these are just how scaling means. And as you know, as I said in previous videos, this study can help us to see the big picture, and by visualizing the big picture we can decide on what steps we should go forward in order to achieve our end result. So let's examine each of these parameters in detail. Before talking about scaling out, let's see how the Instagram backend stack looks like. At the core of the Instagram is the Django that is used for developing application logic. Django has access to other services, and as you know, Instagram utilizes the microservice architecture, so there are many services that Django has access to them. And at the same time, Django can access to Cassandra database and also Postgres database. It also can access to Redis and memcached. And Django can also has the capability to queue tasks. So it has access to RabbitMQ and Celery. So these are just the main components of Instagram architecture, and Django has access to all these components. When a user sends a request to the Instagram, Django receives the request and it tries to create a response for the user. So it may access to other services or read some data from database or in-memory database or try to queue tasks and then responds to the user. This is how the general flow of the information in the Instagram backend looks like. And let's now see how scaling out means. There are some important points that I would like to mention. Instagram uses Django as the main backend server. It receives users' requests and has access to multiple services and storages in order to generate a response for users. Also, some requests create async tasks that are done in the backend. For example, sending notification to user whose photos you liked. These types of tasks are processed by RabbitMQ and Celery. Also, Django has a capability called DB routers, which is used to read and write from different databases. And also Postgres has a replication mechanism that is used to copy data from a Postgres server to another server. Instagram started on a AWS3 server, and after a few months it grew to multiple servers, and after that to multiple data centers, and after that to Facebook data centers, in order to take advantages of advanced monitoring and spam detection services utilized by Facebook. Now the question is how they have scaled their structure, their stack to multiple data centers. There are two kinds of services or servers utilized by Instagram. The first category is storage servers, which is used to store global data that needs to be consistent across multiple data centers with replication. They use Postgres and Cassandra to achieve different type of data. Postgres is usually used to store user information, media, and friendship, status. and etc. This kind of information. And Cassandra is used to store user feeds and activities and such information. The other type of the servers are computing servers, which these types of servers are usually driven by user traffic, and they use RabbitMQ and Celery to handle users' requests. Now let's see how a typical deployment in one region looks like. For Postgres, we have only one master database, but multiple replica, because in social network scenario, usually read per second is greater than write per second. So there is only one master database that Django can write to it, and there are other replicas that Django uses them to read data. Now let's see how they deploy Cassandra in large scale. In large scale, actually there is no master node in Cassandra replicas, and all the replicas actually have the same data with eventual consistency. But what is eventual consistency? Eventual consistency. It is a consistency model that used in distributed systems and computing. It guarantees that if a data item has not updated so far, eventual access to that data will return the latest updated value. Now let's see how Instagram engineers are scaling out their computing servers or services. As I said before, they use Django and RabbitMQ and Celery in each data center to handle multiple user requests. And this structure is usually used for handling async tasks. And as you know, Memcache is also a huge part of the scalability story. It is a high performance key value stored in memory. It should be noted that without Memcache, databases would be collapsed under the high read rate demand, because it provides millions of read and write per second in each server. As a result, it is so sensitive to network conditions, and latency is a big deal here. So this is the structure of computing servers or services in each data center. As we said before, scaling up means that we want to utilize each server with its maximum capacity. To achieve this goal, Instagram engineers use different approaches, but two of them is that they use as few CPU instructions as possible. As few CPU instructions as possible. In other words, to achieve this goal, they have to write good codes. Some functions that are used extensively must be implemented using Python and or C or C++ programming language, because C is extremely fast. The other approach they use to increase the efficiency of each server is to actually decrease the number of servers. In other words, use as few servers as possible. In the first method, we want to increase the capacity, the performance of each server. In the second approach, we actually want to decrease the number of servers. So in order to achieve this goal, the second goal, we should consider two important points. One is related to memory. As you know, to increase the number of servers, we need to use parallel processes as many as possible. But the point is that the number of processes is usually upper bounded by the system memory. The first thing to reduce the memory usage is to reduce the code that resides in memory by, for example, running the code in optimized mode, or removing dead codes, or moving configurations into shared memory. In this way, we can decrease the memory usage of each process and can run multiple different processes in parallel. So we can utilize all the cores of the CPUs, and with this approach we can decrease the number of servers. And the second parameter is the network. And as you know, Django processes requests in a synchronous manner, which has long latency. Also, it has access to multiple services, which increase the processing time of each request. To reduce latency, Django can access services in a synchronous manner. So, by using async, we can actually decrease the response time to a great extent. So in this category, we should use async capability of Django, and in the first category we should do some stuff to actually decrease memory usage of each process in order to be able to run multiple different processes in parallel. Okay, and finally, the third dimension of scaling a platform is scaling the dev team. In order to handle the growing number of developers and also code base, they use source control with no branches. In other words, we have a main branch, and if they want to add new feature to their platform, for example, they want to add direct messaging to their platform, they don't create a new branch. They continue developing in the main branch. And in future, if they want to add another feature to their platform, for example the live feature, they just do it in the main branch. By doing so, they can have continuous integration and continuous monitoring approach, and it enables easy collaboration and also fast revert. So they use source control with no branches. And also, in order to deliver a new feature, they use the following approach. First of all, engineers develop a new feature and test that feature. Then they give that feature to be tested by dog fooders, and dog fooders test the feature and developers improve it. And as you know, dog fooder is a IT slang for when a company uses its own product. After testing the feature by dog fooders, the employees are test that feature, and if there is no error, they send that to be tested by some demographics. And if all those tests passed, they can release that feature to all the globe. So load testing, unit testing are also the main parts of feature shipping. Okay, now that we have an overall understanding of the architecture of Instagram, and also we know a little bit about the software stack of Instagram, I would like to mimic that software stack and that architecture and start developing Collabshare social network platform. So I would like to use event-based microservice architecture for the general architecture of the platform. And also I would like to choose almost the same software stack for developing the platform. For the backend part, I would like to use these software stacks. As you can see, the main backend framework will be Django, and I will use Node.js to develop services such as some sort of real-time services for chatting, push notification, and so on and so forth. For storing data, I would like to use Postgres for storing structured data such as users information and such structured data. For storing unstructured data, I would like to use Cassandra or maybe MongoDB, but it depends on the situation, and it requires more research about to choose which one. But at this moment, I would like to use Cassandra. And for storing the relationships between collaborators, I would like to use Neo4j. It is a graph database, and I would like to use its power to increase the capabilities of the platform. For And in order to decrease the load of the databases, I would like to use Redis and Memcached as a key value in memory databases. And of course, we will need RabbitMQ and Celery for queuing tasks, and HA proxy or Nginx as load balancers. But at the moment, I don't know which one to choose, but most probably I will choose HA proxy as a load balancer, but it's going to be clear as we go further down the road. These are just the for backend section. For the front end section, or for the front end of the platform and application, I would like to use React Native for mobile app development and Next.js for web app development. These are just the initial stack that I would like to start with, and maybe we decide to change the stack over time. But at the moment, I'm pretty confident with this full stack architecture and software stack that I've decided to develop the Collabshare platform. Now let's review what we learned so far. We looked at Instagram architecture and software stack, and we learned that scaling is an important part of every application development. In fact, we must use scaling in our everyday application development for our Collabshare platform. Scaling is a continuous effort, and it is a task that we have to do it on a daily basis. And also we learned that scaling is a multi-dimensional entity. We must scale out, scale up, and scale our dev team. And also we learned that scaling a platform is everybody's responsibility. In the software world, the feedback loop of planning and implementation exists from the beginning to where the software is delivering its service. Continuous monitoring and development are vital to any live app. Due to the rapid growth of information system, and no one understands everything in current real-world information systems. I have provided some references and some resources actually to if you want to learn more. And of course, the web is generous if you want to do some search. And final notes that I would like to mention is that remember to not underestimate the power of small progress. Overwhelm yourself with small progress day in and day out. Add value to society with whatever you know and whatever you have. And also, as Master Oogway in Kung Fu Panda animation said, quit, don't quit. Noodles, don't noodles. You are too concerned with what was and what will be. There is a saying that yesterday is history, tomorrow is a mystery, but today is a gift. That is why it is called present. Be present, my friends. I hope you enjoyed this video. I try my best to keep videos short yet informative, but sometimes it gets longer than usual because this series of videos is actually a documentary series, so it sometimes gets longer than usual. Beginning from the next session, I will start developing the Collabshare platform using the Django framework. So until the next session, be safe and actually be present. See you.